All right, everybody. Our next video and our last video concerning our quantity takeoffs. So I'm not sure what I'm going to do. We have one more week that I'm going to think about what I can fill in, or I'm just going to deliver you the final exam and that'll be it. But I will give you instructions moving forward. We're going to do something to try and deliver as much content as we can. One of the things that we have not talked about that we spend the very last part of the semester on is structural steel and cutting, okay, using an acetylene torch, which is part of our structural steel trades. It's part of other trades too, but it's a significant part of our structural steel trade. So I will probably deliver something on that. Okay, again, you could, if we're up at Ferris, you'd be taking part in setting some structural steel down in the lab. So again, very disappointing that we can't do that, but that's where we would be moving after we got done with our quantity takeoffs. We'd start discussing that and moving forward with that. So I will probably deliver something along those lines. I'm not exactly sure what, but it's not very math based, so it would just be discussion based. But so just look forward to something else. It might just be a discussion via email and some documents or something like that. So, all right, but let's get going with our last two items. Okay, our last two items, again related to one another, are my welded wire fabric and my concrete quantities for my my concrete floor. Okay, so what is my welded wire fabric? My welded wire fabric is similar to rebar. It's my reinforcing for my concrete floor. So if I have a concrete floor like this, I would place that welded wire fabric inside that concrete. Okay, it's a material that comes in sheets or in a roll. Okay, usually in sheets is what we see, and it's all welded together so that creates a welded wire fabric that looks like this. And I would place that inside my concrete. Okay, so if I looked at a section cut of my concrete, I would see that welded wire fabric placed in that concrete. Okay, and again, it's a part of my structural reinforcing. Okay, so thinking about that, okay, first off, thinking about that, what did we say when we talked about my reinforcing for my masonry and my concrete? Okay, if we look at a wall, okay, fairly easy to understand with a wall. Okay, and we've got our footing below here. We made the point that I tie all of that to my footing, and then I tie vertical bar and horizontal bar, making that same type of mat with rebar inside my wall. Okay, get over here so you can see that a little bit better. Why? Because again, concrete has a strong compressive force, but it does not have a strong tensile force, so I can tip that wall over. Okay, well, thinking about that with my concrete floor, where is my compressive force? My compressive force is out here, right? I would actually have to be able to tip that concrete floor up and then push down on it to have the true strength of just the concrete. Out here in the middle, okay, or anywhere else, that's actually a tensile force on my slab. Because of that, we have to put this welded wire fabric in there, very similar to my rebar, to improve the ability to take weight on top of that slab. Okay, because what do we do with our slabs? Simple ones, we might walk on them for our sidewalks, but we also use them for driveways. We use them for dumpster pads. We use them for approaches. Okay, all kinds of different areas that we use concrete in on a construction project. Okay, so again, giving it the ability to carry the weight in a tensile situation, similar to this, but in my wall, I point down. In my floor, my pointing down is my tensile. Okay, so everybody think about that. A concrete slab, 4, 5, 6 inches thick, whatever it is. If I could tip that on its edge and then push in from each side, okay, that would be my compressive force in the case of a slab. Okay, in the case of a wall, my compressive force is pointing down. Okay, in the case of a slab, my tensile force is the force that I place on the slab, as opposed to my wall. Okay, my wall has a good compressive strength, and that's why we use it as a wall. Okay, so again, understanding what my welded wire fabric is. And you guys built your own rebar mat when you when you started to pour. Nobody actually got to pour down in the lab, but you were accomplishing the same thing by building that rebar slab, or that rebar mat inside the slab. All right. So again, looking at our sheet. Okay, it gives us all the information that we want. Okay, we're talking about welded wire fabric first, then we're talking about concrete. Okay, both of those are for the floor. And then we can see that for the welded wire fabric, I asked for it in square feet. And then we can see that for the concrete, I asked for it in cubic yards. Okay, and again, those are related to one another, and we'll talk about it as we move forward. So we go back to our print to understand that. And again, we find out that we have different information on different pages. Okay, first off, I look at my foundation plan again. Okay, I see my foundation plan. Okay, and I can see what have I done here. I have separated that into shapes that I can use, because where is our concrete going to be placed? It's going to be placed all in here and right here. Okay, and it's not going to go all the way from outside to outside. It's going to go from inside to inside, okay, or in this little shape right here, inside to inside, inside to inside. Okay, so we have to think about where that concrete is going to be placed, and in order to determine my total quantity, you can see that I broke this into 3 different shapes. I broke it into the shape, let me see how I listed them. Okay, I broke it into shape A, I broke it into shape B, and then I broke it into shape C. Okay, and then I determined what those dimensions are. Okay, so this is shape A, this is shape B, this is shape C, and then I had to add and subtract as needed to determine my inside dimensions to the inside of my 8-inch concrete block. Okay, everybody should see that. So I want you to do the same thing. I want you to take your practice copy and write A, B, and C. Okay, then we can go through and we can determine those total area for each one of those, and then we can add them all together, and then that's going to give us our total area. Okay, and that's going to be in square feet. All right, and we'll talk about that as we go through it. All right, what else do I need to know? Eventually, I'm going to need to know what? The thickness of my concrete. Okay, but right now we're talking about welded wire fabric, so that's going to be the area of my concrete. Okay, so again, we broke it up into 3 shapes. A, the area for A in square feet, plus the area for B in square feet, plus the area for C in square feet is going to give us our total square footage of welded wire fabric. Okay, so pretty straightforward formula there. Okay, but now we have to go through and we have to determine the area for each one. Okay, so the area for A in square feet. Okay, again, I need my inside dimensions. Okay, so as I look at my drawing, we're just focusing on A right now. As I look at my floor plan, I can see that the information I'm given on one side, 15 foot 4 inches, okay, is exactly the information I want. That takes me from inside of wall to inside of wall. Okay, and then I can see on the top there, my 8 foot 4 inches is the information I want. That takes me from inside of wall to inside of wall. Okay, so shape A is fairly easy. All I have to do, they've already given me, the design team has already given me the information I want. We know that's not always true, and we'll see that in a minute here. I'm going to have to solve for information in order to multiply those two together. Okay, but here, and you can see what I did. Okay, I just determined what those dimensions are, and then I wrote the square footage right there in the shape. So you can do the same thing as I determine it on the board. Okay, and then we'll know what they are. So for area A, I've got 8 foot 4 inches times 15 foot 4 inches. Okay, what do we have to do? We have to convert to decimal feet. 4 divided by 12, 4 divided by 12. So I've got 8.33 feet times 15.33 feet. And that equals 127.70 square feet. Okay, fairly straightforward. Okay, 8 foot 4, 15 foot 4, converted to decimal feet, 4 divided by 12, 8.33 feet times 15.33 feet gives me 127.70 square feet. All right. Shape B in square feet. Okay, again, same thing. I need my length and my width. Okay, but we said that this one is going to be our shape B. Okay, this time, does that give me the information I want? Okay, in one direction it does. I've got 29 foot 8 inches. Okay, we can see that right there. I've got 29 foot 8, right? Yep, 29 foot 8 inches right there. Okay, in the other direction, it doesn't. What do I see? I have to add and subtract again. Okay, because again, I drew my line right there. Could I draw my line up there? Sure. Okay, but then I wouldn't have an even shape down here. So I choose to draw my line right there. Okay, and that gives me 3 clear shapes. Okay, again, I've got one of the dimensions I want from inside to inside, but now I have to determine this dimension right here. Okay, well, what do we have? We have that 15 foot 4, and we know the thickness of our wall. The 15 foot 4 takes me from this point to the inside of that wall. I need to the outside of that wall. So it's going to be what? 15 foot 4 plus what? Well, I could go back to my section cut and understand that because that is my interior wall right here. So it's my 8-inch block wall. So it'd be 15 foot 4 inches. 15 foot 4 inches right here plus 8 inches is going to give me what? 16 feet. Pretty straightforward. Okay, everybody should see that. 15 foot 4, inside to inside. I want to be to the outside. That's 8 inches. 15 foot 4 plus 8 is 15 foot 12, which is 16 feet. Okay, hopefully everybody understands that, inside to inside. All right, so that means that for shape B, I've got 29 foot 8 inches times 16 foot 0 inches. Again, I have to convert. So 8 divided by 12, 29.67 feet times 16.0 feet. Okay? And I get 474.72 square feet. Okay? Straightforward, but again, having to understand what to solve for. Okay, I have to solve for something in order to solve for something else. Okay, and again, I'm setting up this math problem. We are. I decide what the shapes are going to be. I pick the easiest shapes that I can use, okay, but I decide that. Okay? All right, so finally, we've got C, square footage equals that. All right, we go back to our print, and then I ask myself, do I have any of the dimensions that I need? Yep, I have one dimension that I need. Okay, I look at this. Okay, I need inside to inside and inside to inside here. I have one dimension that I need, and that's my 12 foot 8 inches. Okay, we see that. I have this dimension this time. Okay, do I have this dimension? No, I don't. What does it tell me? It tells me 40 foot 8 inches, but where do I see it? Does that take me from? It takes me from outside to outside. That's not what I need. I need inside to inside. Okay, well, the information is right there for me. I've got a 12-inch wall right here, and I've got a 12-inch wall right there. So what am I going to do? I'm going to say 40 foot 8 inches minus how much? Minus 2 feet. Okay, straightforward, but I have to have the ability to see it. Okay, so that would be 38 foot 8 inches. Okay, all right. So I'm going to have 38 foot 8 inches times my width, which is going to be my 12 foot 8 inches. Okay, 38 foot 8 inches times 12 foot 8 inches. Again, have to convert 8 divided by 12, 8 divided by 12. We've already done it once. 38.67 times 12.67. And my units for both of those are feet. Okay, so I'm going to determine that on my calculator, and I get a total of 489.95 square feet. All right, so pretty straightforward. Again, very, very good example of how I have to walk through and solve for each item in order to solve for whatever I need. Okay, First, I had to break it up into shapes. I gave each one of those shapes a name. Secondly, I had to determine the dimensions that I need. Sometimes I'm given the dimensions, sometimes I'm not. Okay? Sometimes I'm given the dimension, sometimes I'm not. Okay? Same one with here. Okay, I had to solve for that needed dimension. But once I have those dimensions, now I can solve through. I can determine what the square footage is for each one of those shapes. And so then my final step is just simply going to be to add those together. So we get 192.37 square feet. Okay? All right, and again, that's going to be close to that. So I am going to order 192 square feet of welded wire fabric. Okay? All right, so I put that one in there. I put that one in my list. And I have my 1,092 square feet of welded wire fabric. All right, so now we look at our last one, okay, our concrete. Okay, we look at our concrete for our slab. And what are we talking about? What do we need? Okay, again, I always determine, you can go back to your list. Okay, again, in the real world, you're going to have to determine this. But I see, and I should know that I'm going to determine that in cubic yards. Okay, I need to know how many cubic yards of concrete I need for my floor slab. Okay, what's the formula for, so number 21, concrete. What's the formula for my volume? Okay, it is what? Length times width times height is my formula for volume. But what do I know? I know that those dimensions are going to be in feet because I'm reading a print. And my print gives me the information in feet and inches. I convert it to decimal feet, and I know those are going to be in feet. What do I want it to be in? Cubic yards. Okay, so what do I have to do? I have to divide by 27 cubic feet per cubic yard, because that's my conversion factor. I know there's 27 cubic feet in a cubic yard, and this is going to be in cubic yards. Okay? All right, length times width times height. Let's change that term. Does not change the formula. But what are we actually talking about here? We're talking about the thickness of our concrete. Okay, that's the same thing as height. It's just a different term. Doesn't change my formula. Still a formula for volume. Okay, length times width times thickness. Okay, and then I divide that by 27 cubic feet per cubic yard. All right, okay, what else do I see? Length times width. Okay, what is that? Okay, length times width is the formula for what? It's the formula for area. So another way to write this formula would be area times thickness in feet. My area is going to be in square feet. That'll give me cubic feet divided by 27 cubic feet per cubic yard will give me the cubic yardage that I want. Okay, why did I rewrite the formula like that? Why didn't I just go through and determine it all again? Because we just determined the area of all of our shapes. That's what we did on the last step. Okay, and again, that's why I listed it out that way. Just like with the block, that's why I listed all the accessory block first and then our final number of block last, because we knew we were going to have to subtract those from my final number of block. Okay, so again, most importantly, what we're talking about here, as I said in the last video, most importantly, what we're ultimately talking about here is the ability to read and interpret this print. Okay, I cannot interpret this print unless I can set this type of math problem up. Okay, again, they communicate information to us. They draw us a picture. That's graphic. They tell us that's written, and then they give us mathematical information. Okay, from that mathematical information, we can solve for whatever we need to solve for. By solving my quantities, I can determine how much it's going to cost to build this building. By solving for my quantities, I can determine how long it's going to take. One is an estimate, one is a schedule. by solving for the quantities of this building, I can determine how many people I need to accomplish that. I can determine what types of equipment I'm going to need to accomplish that. Okay, that's called resourcing. Okay, so again, all of the different things that we do, okay, no matter what area you go into, I have to have the ability to do this math. Okay, so and again, as we get more and more efficient at it, we can start to set up our math problems, what we need to take off most efficiently. And that's why I listed my welded wire fabric first, okay, because now I've already solved for my area, and all I have to do is multiply it by my thickness, and that's going to give me the information that I want. Okay, all right, so let's go ahead and do that. We'll just rewrite one of these formulas. Okay, area in square feet times thickness in feet divided by 27 cubic feet per cubic yard will give me the cubic yardage of concrete that I want. Okay, all right, and by the way, on the last test that you take, okay, your final exam, okay, this is an extra credit problem. Okay, if you remember how to do this, it's not exactly like this. Okay, but it's the same concept. Think about what we're saying, the ability to change formulas back and forth. Okay, the ability to understand length times width times height is the same thing as area times thickness. Okay, all right, very similar problem on the last test. Okay, all right, so let's go ahead and plug it in. We know our area, 1,092 square feet times my thickness, divided by 27 cubic feet per cubic yard. All right, so now I go back to my print and I find out what my thickness is. Okay, it's in a couple different places. Right there, a 4-inch concrete floor with the type of welded wire fabric I need. Okay, I can see it there on that floor plan. I can also see it here on my section cut, 4-inch concrete floor. Okay, all right, so we know that our concrete floor is 4 inches thick, but what do we know we need to do with that? We need to convert it to feet. Okay, so once again, I divide by 12 inches per foot, and that's going to put me into the units that I want, and 4 divided by 12 is 0.33. So I have 0.33 feet. Okay, so finally we have our total formula. And again, we can see that if we understand what we're doing, if we understand how to analyze the print, we can start to understand how to set the math problem up, and it becomes that much easier and that much more efficient. Okay, very, very, very important. Okay, so, and you guys, if we were up at Ferris, I'll be able to demonstrate this in other ways, but again, all I can do is say it while we're lecturing. Okay, in addition to teaching you how to read a print, in addition to teaching you some of the math that we're going to deal with in a print, one of the other things that that I strive very hard to teach you is the ability to be organized. Okay, for those of you, if any of you have any experience, most of you are freshmen and have not been on a big commercial site yet. Okay, hopefully you have internships this summer and you're going to be on a big commercial site. Okay, some of you have some residential experience. A few of you do have commercial experience. Okay, I'm thinking of one student in particular. Okay, but once you get on a commercial site, or if you've been on a commercial site, pay attention to how much information flows through that site. There is a massive amount of information that flows through a big commercial site. Remember, we're talking multi-millions of dollars for the projects that you guys are going to be on. Okay, you don't just guess at that. You know exactly how you're going to do it. You're very, very organized throughout the entire process. Okay, so you guys need to learn, you need to start to train yourself to become very, very organized. Some of you, that's your personality by nature. My son is that way. He's extremely organized just by nature. Okay, I'm fairly organized by nature. Okay, but other people, I've gotten much better at it over the years. Okay, because I've understood the importance of it. Okay, it's very, very important that I stay well organized in every single area of my life, but definitely at work. If I want to succeed in the construction industry, I'm very organized. If you guys ever came onto one of my job sites, you would see that. Okay, everything has its place, and there's a place for everything. Okay, I understand the importance of organization and communication. Okay, so again, I'm also teaching you those concepts. That's why I laid everything out the way that I laid it out. Okay, all right, so we walk through, we do that math, fairly easy math. We know that my cubic feet are going to cancel. Okay, my square feet times lineal feet is going to give me cubic feet, so that's going to cancel. I walk through there and I find out that I have 13.35 cubic yards. Okay, so in this case, who knows what we can order concrete by? Some of you do, some of you don't. Do we order it by the full yard? No, we can order concrete by the half yard. Okay, so in this case, I would give it to you for 13 and a half, which would actually be the right answer, or 14. Okay, but by experience, I understand that I can order by the half yard, so the right answer, if I were actually ordering it in the field, I would order 13 and a half cubic yards of concrete. Okay? All right, so again, that is it for our quantity takeoff. You guys should all now be ready to complete